Alright, in this video I want to go through a longer article by Martin Fowler, which was published in late April 2026. It's about structured prompt-driven development. And I thought I go through and read through the article and I will give my comments alongside. I was investing significant amounts of times in the last weeks and months on the question on how we can orchestrate AI engineering, agentic engineering, vibe coding. I don't like the word vibe coding, which I expressed in many articles in the past. Yeah, but I thought this article is very interesting because it's really about how agentic coding can be done today and in the upcoming future. I think the future and how we're going to build, in the end, products and how we orchestrate and organize development teams or even whatever knowledge worker teams is not written. So the structured prompt development approach or concept quickly caught my eyes because I'm super curious how this is seen by industry leaders like Martin Fowler. So yeah, I assume that this video will be quite long as I'm going and reading through the whole article, so it's quite a long piece. So if you want, I highly suggest you to basically listen to it, and maybe it's almost like podcast style of listening. And you just follow along, and I hope you also find it inspiring to see what structured prompt-driven development actually is, outlined by Martin Fowler. Okay, let's start. How to make LLM assisted changes governable, reviewable, and reusable. Yes, so you see already it's all about how can we make controlled, reviewable, reusable software projects and not just vibe coding, right? So it's all about that. How can we basically use AI for structured and for reliable and outcomes? LLM programming assistants have demonstrated considerable value, but mostly with individual developers. The internal IT organizations in ThoughtWorks has been using them for their teams and have developed a method and a workflow called Structured Prompt-Driven Development, SPDD. The article describes a simple example of this workflow with details in GitHub. This workflow treats the prompts as first-class artifact, kept with the code in version control and used to align development with business needs. We have found that developers need 3 key skills to be effective: alignment, abstraction first, and iterative review. Okay, so this was the introduction, summarize. So the authors here, and then you see there are many chapters or many sections we can cover. All right, so once a team adopts AI coding assistance, the first gains show up at the individual level. One developer can draft, modify, and refactor code much faster than before, but delivery speed is rarely limited by typing. When you look at the full delivery lifecycle from requirement through release, new friction appears. Ambiguous requirements become code quickly, and misunderstandings scale with them. Reviews have to process more change, and inconsistency becomes easier to introduce. More integration and testing issues surface because generated doesn't mean aligned. Production risk is harder to reason about when the volume of changes rises. Yeah, I would highly agree on this. This is exactly my experience. So specifically as an individual, you can bring up and bring to life a new application very, very quickly. These are all the LinkedIn posts you can read these days about, whoa, coding will be dead and I could build that in 10 minutes or in a weekend. So yeah, fair enough for that. But if you want to build professional software, you obviously, and as outlined here also, you need a better process. So yes, local speed improves, but that doesn't automatically translate into system level throughput. It's like buying a Ferrari and driving it on muddy roads. It's like buying a Ferrari and driving it on muddy roads. It's an interesting thought. The engine is powerful, but yet your arrival time is determined by road conditions and traffic. In our experience, the real question isn't how do we generate more code? It's how do we make AI-generated code governable, reviewable, reusable, so teams get faster and safer. That led our ThoughtWorks internal IT teams to a method and workflow we know called structured prompt-driven development. SPDD aims to turn AI assistance from personal efficiency into an organizational level capability that scales without trading away quality. Yeah, okay. Just my first impression is they really try to come up with a new term. So I don't know, it's maybe also a bit of PR that you could say, okay, ThoughtWorks invented the SPDD process. So it almost reads like that. So far we haven't read something new and innovation with some innovations. All right, so there is iteration n+1, there is a business intent, and there is something they call the reasons canvas, which I think they will explain in the article. Then you have structured prompts, versioned, reviewable, reusable. Then you generate code, you test it, and then you basically do that. And then over time, this accumulates not only the code, but also the prompts applied to it. So if this is the whole innovation, I would be a bit surprised. It's not really an innovation. Okay, prompts are first-class delivery artifacts. Okay, that's a statement. I would agree that this is the case for more than a year already now. What is SPDD? Structured prompt-driven development is an engineering method that treats prompts as a first-class delivery artifact. Instead of relying on ad hoc chats, SPDD turns prompts into assets that can be version-controlled, reviewed, reused, and improved over time. Teams use structured prompts to capture requirements, domain language, design intent, constraints, and task breakdown. Then the LLM generates code within a defined boundary, so output becomes more predictable and easier to validate. It has two core components. Again, it seems natural that the prompts are actually the source code or are like the more abstracted source code, and that's why they also need version control. But then they've kind of built a reasons framework, and let's dive in what this is. The reasons canvas. The reasons canvas is a structure for generating prompts. It forces clarity around requirements, domain model, solution approach, system structure, task decomposition, reusable norms, and safeguards. So the LLM is guided by intent, not guesswork. The reasons canvas is a 7-part structure that guides a prompt from intent, design, execution, and governance. So here is the visualization, like an infographic kind of thing. SPDD reasons canvas. So there is this main area with the abstraction part, requirements, which probably defines the intent, describe the essence of the requirement clearly in one sentence. Then there is the entities, basically, the domain model, the data abstraction layer, the description of the data abstraction layer. Then we have the approach, explain high-level solutions and collaboration structure, defines inheritance, relationship, and dependence. Then specific parts, so abstraction parts, specific parts, operations, decompose abstraction tasks into concrete, reviewable, executable tasks. Okay, see, so this is kind of the specification, the abstraction of the specification, but then you not only have that, you basically have then the delivery, the operations, so basically the tasks that describe what needs to be done, and then they obviously, or it seems so that they also include the reviewability, basically testability. And I already like this approach actually. So just to have a canvas to say, hey, we have this abstraction, and then we have the description on how we're going to develop it, and then cross applies to all section, common standard parts. Okay, you have norms, cross practice, best practice, etc. And then you have the safeguards, governance, guardrails. So this is kind of the base agreements, norms, whatever you want to call it, that are, I would say, additional context that gets injected into the work that happens here. All right, I think it's interesting to see. What I kind of miss here is software not only is in a development state, so it's very likely you have a production software, it's very likely you have a continuous integration process, and I don't see that here. So this is, it seems that this recent canvas just thinks about the specification and not really about continuous delivering the software solution, which adds additional complexity. Well, maybe they will bring that up later in the article. All right, so requirements, entities, approach, structure, abstract parts. Requirements, what problem are we solving and what is the definition of done? Entities, domain entities and relationships. Approach, the strategy of how we will meet the requirements. Structure, where the change fits in the system, components and dependencies. And then specific parts, execution, operation, break the abstract strategy into concrete, testable implementation. And then common standards, norms, cross-cutting engineering norms, naming, observability, defensive coding, safeguards, for S, non-negotiable boundaries, invariance, performance limits, security rules. So that makes up reasons. Wow, what a nice abbreviation. I don't know how much time they invested to come up with all these names that it actually becomes the reasons canvas. Very well done. So that's a nice read. The canvas aligns intent and boundaries before code is generated. Moving uncertainty to the left because the structured prompt captures the full specification. Reviewers reason about a single artifact instead of scattered chat logs and partial diffs. By following the same structure, every prompt becomes governable in the same way. And as domain knowledge and design decisions accumulate in each prompt, they compound individual expertise across iterations and reduce variability across teams. Yeah. I like that. It sounds very concise. I specifically like that there is this basically first step where you abstract, and you not only abstract it as a markdown file and say, okay, this is my specification, this is how I want. They actually come up with these 4 kind of perspectives on a requirement, the requirement itself, the entity, the data, then the approach. Kind of the approach and structure for me is very similar. Maybe I didn't fully understand the difference. The strategy of how we'll meet the requirements, where the changes fit in the ecosystem. Okay, so maybe this is more the architectural decision, and then structure, where the change fits in the system. It's also kind of the architectural decision. Maybe it's more overall, and then whatever. But there are different perspectives. I kind of like that. Let's go on. The SPDD workflow. The workflow brings prompts into the same discipline as code, commit history, review, and quality gates. It also enforces a simple but powerful rule. When reality diverges, fix the prompt first, then update the code. Over time, this changes how teams work. Reviews move away from spot the bug towards check the intent. Rework becomes more controlled, and successful patterns naturally accumulate into a reusable prompt library that supports AI-first software delivery. Yeah, so I kind of liked this just as a ground idea that the prompt is basically the definition of how the software will look like in the end. So you're not updating the code, you're updating the prompt, the specification. I'm not sure if prompt is actually the right word, but okay, they picked that, but it's more like you update the overall context of a software product, and then based on that, you regenerate the code, right? And it's true that once you do that, you always look at the intent. So what do we actually try to achieve with this code? And this is not written in the code in that sense, because the code is the deliverable of the intent we try to do, right? So why not fix first the intent and then the code? To be honest, as nice and as cool that this sounds, this is not my my experience in reality. I mean, in the end, once you have code and there is a bug, I don't think for a small bug that you recheck the overall intent. It takes way too much time. If you want to do that, you can do that, but I wouldn't do that per little bug. I would do that and that's what we do quite a lot. So once we are in a delivery mode, when we create software, we also have tickets basically. It's like markdown files, but in a visual ticketing tool. It's not Jira, it's a custom built tool. And we add a section per ticket learnings. And every now and then, typically every week, we go through all the past delivered tickets and we go through the learnings, basically what the AI or the AI assistant coding got wrong. And then we collect all the feedbacks and then we will improve our skills and also our prompts for the overall benefit and the compounding effect of having better prompts and better skills over time, right? So it's a similar approach, but if I understand it right, and if you want to do pure SPDD, you always go back to the prompt, fix that, regenerate the code, and then you have the software. If you've known about spec-driven development, you'll recognize the same starting point. Write the spec clearly first, then let the model implement. SPDD takes a different angle. It treats structure prompt as governed, reusable, versioned team assets, reasons plus workflow that evolve alongside the code. An approach that Brigitta Böckler categorizes as a spec-anchored approach. Yeah, okay, this is a bit kind of a high-level discussion and how to look at it. But yeah, it's true. Obviously, spec-driven development is very, very similar. You have a spec, and then based on that spec, you partially generate the right code, and then you can always update the spec alongside. So yeah, that's good. The goal of the SPDD workflow is to turn business input then to abstraction and to execution and to validation and release into a closed loop, and to make sure prompt assets and code evolve together, not separately. Yeah, so it's just, again, the process, how that works. So there is another infographic: create initial requirement, clarify analysis, generate analysis context, and then you kind of integrate that in the reasons canvas, analysis context, and then you generate a structured prompt. Once you have that, you also have that in Git, then you generate the code, you generate the unit tests, and then you integrate, build, and deploy the whole thing, right? Okay, so let's go through that. What SPDD adds to spec-driven development? So what's actually the difference, or what is the addition? STD and SPDD share the same starting point. Generate a spec before generating code. SPDD adds a method for how that spec is produced, reviewed, and kept in sync with the code. The prompt is a maintained artifact. It is not generated once and discarded. It goes through a defined workflow and stays the record of what was intended. Well, I would say STD is exactly that. You always keep an updated spec. From requirements to engineering spec, the reasons canvas goes beyond what the system should do. It captures the chosen approach, system structure, engineering norms, and safeguards, giving the LLM an implementation boundary, not just the goal. Okay, so now it makes sense. So you basically, in the reasons canvas actually suggests that you not only have the spec, but you basically have additional context as written here. So it's not only the requirement, it's actually the way, I mean, in spec-driven, you would have a specification of the entities. You would maybe also have a description of the approach. But as I understand, in spec-driven, you never do the actual kind of executable tasks definition. And as I understand, the reasons canvas would generate also the tasks that need to be done to generate to actually generate the code that is defined in the requirements. So it's an interesting approach. That's why LLMs are good in basically generating stuff, and why not pre-generate the tasks to be done to actually implement the specification. Sync, not handoff prompt, and code stay synchronized. Changes on either side are reflected back, so intent and implementation do not drift apart. Repeatable team control. The point is not more detailed specs, but a consistent way for teams to govern AI output and carry what was decided forward across iterations. The trade-off analysis behind those decisions lives in an analysis phase. The canvas records the outcome. Yeah, okay. Yeah, it's interesting. I see it's clearly approach to a more controlled and repeatable process. And yeah, I start to really like the thinking behind it. Especially just what we went through now, spec, the basically task list, and the overall context. And this is actually the software, and you can always generate or regenerate the software that's specified like that. I like it so far. Let's go on. So it's a long article. The aim of this workflow is to anchor collaboration on the prompts so that developers and product owners can avoid repeated cycles of alignment. The prompt sets an explicit boundary for code generation, reducing the randomness of the LLM's non-determinism, making it easier to govern. By treating the structured prompts as first-class artifacts in version control, we turn successful practices into reusable assets, improving consistency and reducing reinvention. In practice, these steps are carried out through commands like Open SPDD, a command line tool that implements the SPDD workflow. The table below summarizes each command. Okay, this is very interesting. So instead of having this concept just as a skill, they actually have a CLI. I think it's a CLI. Let's quickly open up that. So it's quite fresh project as well. That helps you, to go through that with commands. Or is it skills? I'm not sure. Oh, okay. Oops, sorry. Okay, there's a couple of commands that the Open SPDD tool offers. So command type, purpose, it's a table. SPDD story is the command. Breaks a large requirement into independent deliverable user stories following the INVEST principle. SPDD analysis. Extract domain keywords from requirements, scan relevant code, and produces strategic analysis covering domain concepts, risks, and design iterations. This design direction. SPD Reason Canvas generates the full reasons canvas, an executable blueprint for high-level rational down to method-level operations. SPDD Generate reads the canvas and generates code task by task, strictly following the operations, norms, safeguards defined in the prompt. SPDD API Test generates a CURL-based API test script with structured test cases covering normal, boundary, and error scenarios. SPDD Prompt Update incrementally updates the canvas when required, when requirements change. Requirements prompt code. SPDD Sync synchronizes code side changes, refactoring fixes back into the canvas, so the prompt stays an accurate record of the current code to prompt. All right, very interesting, very interesting. So what they actually come up with is a little software helper that incorporates the process. So for everybody, it's the same. So once you want to think a software development team, if they build a big software piece, the process of delivering that software is basically woven into these commands. So there is, as I understand, the only way to add a requirement is by using this command. Or the only way to actually generate the code is by running this command. So it's basically, I really like this idea. And interestingly, we have a similar approach, even though not that thought through as this one is. Okay, this is very interesting. I like that. Let's go on. I think it's just interesting that it seems that we need a new kind of, let's say, developer tool that helps guide through a new kind of process. It's just interesting that they came up with this piece of software. You could argue that in the end, you could just leave that up to the developer, because a software engineer needs whatever freedom to think through and basically act with his own reasoning. But it seems that there is a new way of, let's say, defining the workflow, which is then tool-based. I mean, it's not entirely new. Obviously, we had CI/CD pipelines in the past, and they really much structured also the whole process. But just leveraging the LLMs through all these different prompts in this high-level overview and concept of the reasons canvas, I kind of start to like it. All right, now I think they come up with an example. Enhancing a billing engine with SPDD. A complicated workflow is difficult to understand in the abstract, so we have prepared an example workflow of enhancing an existing software system. This system and its enhancements are necessarily small in order to comprehensively within a tutorial article. That said, the enhancement example is full end-to-end example for creating initial requirements, to analyzing business requirements, to generating and reviewing a structured prompt, to producing and verifying code, to final cleanup and testing. You can follow along with this example by installing OpenSPDD in your own environment. The current system. The current system is a simple billing engine that calculates bills for using a large language model. It accepts a record that captures how many tokens are used in a session and calculates a bill. The complete code base for this initial version is available on GitHub. The repository includes the initial requirement story and all the SPDD artifacts used to generate it. For brevity, we don't describe the initial generation here, but it follows essentially the same steps as that for the enhancement. We focus on describing the enhancements because most work on a system are enhancements. Yeah, that's what I said. You typically have an existing software. And so they come up with this example here. Let's quickly open up the initial requirement story just to see how that works. Okay, so there is this project token billing. Let's make that a little bit bigger so you can read it. They have the background. Okay, they also describe the business value, accurate billing, quota management, revenue capture, scope in, implement post API usage, blah, blah, blah. Scope out. Okay, so it's a clearly defined what's in, what's out, and then the acceptance criteria is also here. So this is the initial one. Then there is the source code, Java software. So I kind of understand now the structure. So there's the requirements. There's one MD file. Okay, it's just the README, and then JavaScript, a Java project here, and then a code. Okay, so that's the initial state. And all the SPDD artifacts you use to generate. Let's also open up this one. Okay. Okay, anyway, I don't want to lose too much time to go through that, but I see now the initial requirement. That was interesting to see. So now let's go on with the example. The enhancement. Driven by evolving business requirements and direct user feedback, we are enhancing the billing engine to transition from a static pricing model to a more sophisticated, flexible infrastructure. This update aims to support diverse subscription strategies and variable, more specific pricing through the following key changes. API enhancement, update existing post API usage endpoints, etc. Model-aware pricing, shift from a single global rate to dynamic pricing, blah, blah, blah. Multi-plan billing logic. So it's some additional features. There's a standard plan, premium plan, architectural scalability, implement an extensible design pattern such as strategy or factory to cleanly isolate the calculation formulas for different plans, ensuring the system can easily accommodate future pricing models. Since this new section encompasses both business requirements and technical details, it is typically completed collaboratively through a pairing session between PO or BA and a developer. Yeah, so interesting, and I think this is a very realistic enhancement. So it's on one hand the overall business requirement, so we need more flexible pricing, which then leads into API changes and even architectural scalability questions. So yeah, it's actually quite a sophisticated change on top of an existing software solution. So now, how does the SPDD process work? So step 1, create initial requirement. To kick off the process quickly, we can use the SPDD story command to generate user story directly based on the enhancement. Generally, user stories are provided by the PO. However, in our workflow, we can transform stories of any form into a consistent format and dimension. As long as there is a shared alignment on the final acceptance criteria, this step can be performed by a PO, BA or a developer, depending on the team's flexible divisions of labor. Yeah, I think this is already an interesting learning because we are no longer working with code per se and probably also not working in a coding environment. This story generation can be done by a product owner, business analyst, or of course also developer. But bringing this capability or this work to more, let's say, non-technical people, there is a lot of potential to actually make a clear initial requirement specification through this software idea. So instruction is SPD story, and then you just link to that MD file. And then the AI analyzed the enhancement description and split it into 2 user stories. Story 1, standard plan, model-aware pricing. Story 1 and 2, premium plan and split rate plan. So based on that story generated, the AI came up with 2 stories. So it's basically the requirements to story transformation in that sense. The auto-generated stories are detailed enough to serve as a baseline for a formal project. For this walkthrough, we consolidated them into a single simplified story, so the example stays self-contained. Okay, consolidate the following 2 user stories into a single simplified story. Requirements, merge both plans, blah, blah, blah. Merge only the sections, background, business value, scope in, acceptance criteria. Instruction of this kind rarely produce identical text on every run. Models and sampling introduce small difference, so we still expect to review and tweak the output before treating it as final. The combined story below is the version we refined for this walkthrough. A deliberately simplified consolidation of the 2 initial stories. Yeah, I think it's a bit strange that in this example they generate 2 stories, which is very realistic. This is exactly how we do it too. And then they make this in-between step to merge it again, just to keep the example consist. Well, whatever, it's how they do it. But then there's the combined user story simplified, and then you have you have this structure here with scope in, scope out, background, business value, acceptance criteria. Maybe here was a side note that how SPDD story works. This command breaks a large requirement into independent deliverable user stories following the invest principle, 1 to 5 days of work each. Each story includes acceptance criteria written in business language, ready to serve as a input for SPDD analysis. Its purpose is to make a large requirement manageable and to ensure a standardized, predictable format for the next step. I see. So, yeah, it's interesting. So it's like a multi-step process. You have a initial business requirement, then you create this, basically the story, and then you actually build a more technical, I would say, requirements description in step 2. Let's read what they come up with. Step 2, clarify analysis. Before jumping into implementation, the developer reviews the user story to build a shared understanding of what it means in practice. If there are obvious business level issues, this is the point to align with the BA or PO. In this case, the story is clear enough, so we move straight to breaking it down along 3 dimensions: core logic, scope boundaries, and definition of done. Yeah, so one thing to learn here is, and I think this is also interesting, and specifically if you compare it to vibe coding, where typically one person is just pushing out a software product. In a larger project, you always have a customer or whatever, stakeholders. And it's interesting that once you have this process of creating the initial requirements and then scoping out the, let's say, the stories, then you have an artifact. You can go back to the stakeholders and basically discuss what, if that's actually what we want to do, and if that's actually what we need to build. So this is a nice learning. I'm a bit confused why now they come up with core logic, scope boundaries, and the definition of done. Is that still in this requirement build, or is that already basically in the additional context? So this is the first time they call that out: core logic, scope boundaries, and definition of done. Let's see how that comes together. Core logic. One new requirement field on the API. Model ID, the customer now tells us which AI model they used. This is the key that unlocks the right price. I'm now a bit confused. Is that written by whom? Is that the AI that comes up? Or is this just additional context written by whatever, the business analyst or whatever? Okay, so standard plan, customer has monthly token quota, usage, so this is just the description. Premium plan, routing, the system determines the customer's plan and dispatches to the matching billing formula. The design must be easy to extend, enterprise plans, etc. Scope boundaries, we are only calculating the current bill. We are not building customer CRUD, not querying historical bills, not managing subscriptions, and not adding and removing models. Yeah, this is, I'm not sure if this is realistic, because typically how clarifying analysis, so once you have the specification written out, then you clarify the analysis with stakeholders, you add core logic, scope boundaries, and definition of done. The following scenarios restate the story's acceptance criteria with the implementation detailed. The team needs to verify. The 4th item, response format, is not a new business acceptance criteria. It captures the non-functional contract the developer adds to make the criteria testable end to end. All right, so this is just additional, let's say, basically specification, context, definition of done. So this can then also be tested. If all the scenarios pass, we conquered this story. Yeah, so my critique here would be this, let's say, clarification, what we actually want and need, is not always obvious when you go and start a project. Of course, what you want is, that's the business intent, you want a standard and premium plan. But what does that mean actually for the implementation is not obvious. So it's not clear that you need a routing system in the first place. This typically, and this happens a lot of times to me, I start a project with an initial version and then I look at it and I'm not able to think through end to end what this feature should look like in the end. So it's always multiple iterations and even approaches. And this is what agentic engineer makes possible. I can build a prototype very quickly. I don't want to vibe code a prototype. I want to have this ground rules and the quality rules around it. But from a features perspective, it's not always clear what I need. And they kind of assume that in step 2, you already know what the full feature set would be based on where we are in the process. And this is not, I think, realistic. Even though, and I think they have an answer to that, is this review loop. Obviously, as much context as you can add, it's even better. And typically, you can add a lot of context beforehand. It just needs you to actually put that down and work on that. So step 3, then generate analysis context with the requirements and scope clarified. We use the SPDD analysis command by feeding it the business requirement, and we instruct the AI to generate a comprehensive analysis context. Instruction SPD analysis, then you add the user story, multi-plan billing foundation, and model-aware pricing MD. So generated the artifact, the initial analysis context document. So actually I want to look at that. So now this is not only the requirement. Let's go back. Actually, it's SPDD. This is the requirement. And then you have the SPDD, which is analysis. And then you have the analyze. And then here, I would assume this is the original business requirement. You have the background, business value, scope in, scope out, acceptance criteria. Then you have the domain concept identification. So you have existing concepts, you have the customer pricing plan, etc., etc. New concepts required, plan type, blah, 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 key business rules. Strategic approach. So here are all these boxes we talked about before. Solution direction, key design decisions, alternatives considered. Okay, so it's even writing kind of down the reasoning why it chose or why it was chosen to go with this approach. Risk gap analysis, so interesting. All right, it's a quite technical risks, acceptance criteria coverage. I see. Okay, so it's, I mean, what I learn here is, again, from business requirements to outlining stories, then to actually create more context, analysis context, which then can be used to generate code. But let's go through and follow the article. This command produces a strategic level analysis grounded in actual code-based exploration. The output focuses entirely on the what and why, deliberately avoiding granular implementation details at this stage. Yeah, so if I understand it right, this command is inspecting the actual existing code because it lives in the same repository. This command produces a strategic level analysis grounded in actual code base exploration. And then, yeah, it just writes it into this SPDD analysis MD file. Okay, domain concepts, existing new relation, business rules, strategic approach, solution direction, design decisions, trade-offs. That's what we looked at. Risk gaps and ambiguity, edge cases, technical risks, acceptance criteria, coverage. Review and refine the analysis context. With our own understanding of the business requirement in mind, we review the generated analysis content document, focusing on the areas highlighted in the alignment skill. This review serves two purposes: confirming that our understanding aligns with the AI's interpretation and discovering the edge cases or boundaries scenarios the AI might surface what we haven't considered. In this specific instance, the review focused on several critical areas: whether the strategic patterns were appropriately considered, adherence to the OOP principles established in the existing systems, specifically ISP and SRP, the validity of the proposed strategy for adding new fields, identifying edge cases not previously anticipated, uncovering potential technical risks. Upon completion of the review, the AI's analysis largely aligned with our architectural intent. In fact, its considerations were even more comprehensive than ours in certain areas. Yeah, okay. So again, we have another deliverable, and with that, we can look at it and we can go back to stakeholders and discuss if that's even feasible, or if it's actually a good solution in the end. And there's one, and it's also my experience. The AI is very good in finding edge cases and also pointing to it. And as it is in the life of software engineering, things can become very quickly very complex and complicated. And so, that also come here. They describe the edge cases and technical risks, which then you can answer before you even ever have created code. And so you can address these edge cases beforehand, which is obviously a valuable thing. To be transparent, at this stage, we only process a high-level conceptual alignment. While we can quickly envision the implementation for areas where we have prior experience, we cannot completely map out all the granular technical details for the unfamiliar parts right now. So this is what I've thought out before. However, that is perfectly fine. The overarching direction is aligned. We can proceed to the next step, observing how the AI simulates the concrete implementation details within our established framework and context. Once we have these tangible details, we can uncover deeper hidden issues and make informed trade-offs based on the actual scenario, adopting the approaches where the benefits outweigh the drawbacks and discarding the rest. Decision: accept analysis as is and proceed. All right. Now, generate structure prompt. Instruction: SPD reasons canvas, and then you again take that MD file, and then you generate a new artifact, the initial structured prompt. Let's look at it. So now, based on the context analysis document, there is actually now an implementation kind of plan. And again, it repeats the requirements, key capabilities, and then it makes a visual representation of the entities. I don't know if you need that per requirement, but anyway, I have my opinion about it and I will share it later. So the approach, so it kind of comes with a step-by-step approach almost. So you have steps here, then schema evolution. It clearly says what needs to be changed in the schema. Strategy pattern implementation. So there is a more like software architectural kind of description that we need new interfaces, blah, blah, blah. Strategy resolution, create billing strategy factory. Okay, model pricing, domain model updates, service domain model operates, schema evolution, domain model updates. Okay, so these are the classes basically. Okay, so anyway, it seems that there is a step-by-step, very detailed description what needs to be done. There's again a repetition of the design principles, inheritance relationships, dependencies. I'm really not sure why you want to repeat all this, because the AI has access to the code. Why do I want to have all these copy-pasted more or less if, for example, I already have my drizzle models pointed out? Why do I need this entities overview if I have that in code? I don't know. And let's think about prompts. Let's say how many prompts are there already here. So you have 4 prompts. In a large software project, you will have probably hundreds of prompts for features inside the software. And if I understand it right, they repeat. No, here is no entity. Okay, I don't know exactly what this is all about. But anyway, I think you just produce a lot. Here is again. So you have here the customer. And then in the other one, you likely also have the customer. And then, I don't know if that makes sense to keep all the different prompts up to date. Maybe I'm wrong. I'm just thinking loudly here. What I like anyway is that there is a step-by-step description, and also how, from a developer perspective, how I want the AI to actually implement these specific requirements. But why include norms here when a norm can be a norms MD file? Why repeat that and copy that overall prompts? Maybe I misunderstand that, but yeah, okay. All right, so there is this generate structure prompt. Let's go on. Maybe we get some more insights here. By this point, we've already gone through high-level strategic during the analysis phase. So when reviewing the structure prompt, we are not starting from scratch. Instead of, we are examining how the AI has translated our shared understanding into the reasons canvas structure, from strategy to abstraction to concrete details. Yeah, I mean, this is really, I think, valuable, especially that you are not starting from scratch all the time. So during these 3 steps before, we accumulated a lot of context for building up a prompt that is far more superior than when you would just vibe code, open up the code and say, do this for me. So that's for sure something that generates and produces much better quality code. And then think of it as a progression. The analysis phase gave us strategic clarity. Now we are checking whether the clarity has been faithfully carried out through the architectural abstraction and implementation specifics. This is intent alignment at a deeper level, ensuring that before any code is generated, AI has effectively simulated the entire solution within our defined framework. We get to review from a global perspective rather than getting lost in the details from the start. Yeah, I like that. We get to review from global perspective rather than getting lost in the details from the start. I kind of agree with that, but I have the feeling that we get lost in these long prompt files. But anyway, focus the review on the areas highlighted in the abstraction first skill. In this case, this foundation context is already embedded in the code base and the previous structured prompt. Consequently, when generating the structured prompt, for this iteration, the AI naturally factors in these architectural guidelines and OO principles. As a result, even though the generated code is highly complex, there are remarkably few major issues. We can opt to proceed with generating the code using the structured prompt first and then conduct a deeper review to identify any potential code level anomalies later. So far, we have reached a strong consensus at the intent level, clarifying both the core problem and the solution path. While there may be slight omissions in the details, this is not a concern. Having aligned on the overall scope with the AI makes local optimization highly controllable. Now we transition into the code generation phase. Interesting. Okay, now finally we generate code, step 5. This step is more involved as we are as we are generating the product code, tests and our reviews have two alternative outcomes. The generate product code. Once our structure prompt is logged in, use it to generate the product code. The instruction, again, with the command line tool or with the prompt, with the skill tool, SPDD generate, and then you just give it the empty file which was generated before. Generated artifact, code generated based on the structured prompt. Thanks to the multiple rounds of logical deduction we did earlier using structured prompts, we approached the code review with a clear focus and set of priorities. Architecture, does the code strictly follow our expected 3-tier architecture? Business logic, does the service layer implementation perfectly align with our initial intent? Scope of change, are the modifications strictly confined to the boundaries defined by the structured prompt, avoiding unrelated changes or scope creep? In this specific case, thanks to the highly precise context, the generated code largely met our expectations, aside from a few potential magic numbers. We will optimize these out once the functional verification is complete. The key takeaway here is, don't worry about making mistakes and don't stress over not catching every single detail perfectly on the first try. As long as we keep iterating and advancing through the SPDD workflow, there are plenty of opportunities to course correct. Minor code smells are fine for now. We verify the core functionality first, then we circle back to optimize. Yeah, okay. Let's go on. Feature verification. During feature validation, SPDD workflow provides the SPDD API test command to generate functional testing scripts. Generate artifact, the API test script. Okay, so now it generates a shell file. I don't actually understand why we are not using a proper test framework, actually. Why do we use a shell file here? I mean, why not? But I would go for a testing framework which then integrates in a higher ecosystem of testable observability, basically. Guided by the defined rules in the command, the AI generates a script that formulates the required test scenarios using CURL commands. We can review the AI-generated scenarios in the test case overview section of the script. Okay, so it just comes up with basically a test script. Execution, once the script is generated, run it. Results, all functional tests pass successfully. All right. Code review, final adjustments. Thanks to the rigorous intent alignment in the first several steps, the heavy lifting is already done. At this stage, the remaining issues are usually minor logic discrepancies or service level code smells. To maintain precision in our engineering practice, we categorize these final adjustments into 2 distinct types based on whether they change the system's observable behavior and handle them using different strategies within the SPDD framework. So yeah, once we review it also as a human, there is a logic correction. So we need to actually update the prompt. I see. So this is what I talked about before. So if there is a logic issue, we need to correct it. We update the prompt and we regenerate the code. If it's more kind of a refactoring, AI came up with not a so good idea, we update the code manually and then we sync the prompt back to the initial prompt, which then includes this, let's say, human-made, human-in-the-loop decision to do something differently. Yeah, I kind of like that. The sync prompts, I think this is also a command, a skill. Okay, 2 responses to code review changes, logic corrections. The behavior needs to change. Strategy, update the prompt first, then generate code. For issues related to business rules or logic mistakes, which inherently change the observable behavior of the software, always update the structure prompt to lock in the correct intent before touching the code. This is an update or bug fix, not a refactoring. For instance, when persisting model ID in the bill, we currently allow this field to be nullable. The underlying reason is the need to maintain backwards compatibility with historical data, making this workaround a reasonable architectural decision. Prompt needs update. However, there is an alternative. If the business stakeholders can confirm what the model ID value should be prior to this change, we can unify the system's behavior and eliminate this potential technical debt. Let's assume that after confirming with the business that the model ID for all historical bills should be set to fast model. With this clear intent, we interact with the AI instruction. Okay, there is an update command. Model ID is a required field and its default value is fast model. Based on this decision, update the corresponding parts of the structure prompt. Okay. The AI updates the structure prompt based on this instruction. Updated artifact, the updated structure prompt. Okay. Once confirmed, use the SPDD generate command to update the corresponding code based on the newly updated structure prompt. I see. The AI guided by the rules defined within the SPDD generate command comprehends the required changes and performs targeted updates exclusively on the affected code base. Updated artifact, the updated code. It is important to note that we do not regenerate the entire code base. We continue using the existing structure prompt and the AI handles the targeted diffs. Identify the mismatch. Notice that the behavior of model ID during persistence is inconsistent with the new business requirement. It must be mandatory with a default. Target the prompt snippet. Copy the specific section from the structure prompt that defines the outdated logic. Update the prompt, paste the extract snippet into the chat alongside the revised business rule. Instruct the AI to update the structure prompt first. For generated targeted code updates once the prompt reflects the new truth. Run SPDD generate pointing to the updated file. The AI automatically performs targeted diffs exclusively. I don't know if this, if you have a agentic tool like Claude Code or Codex, you would not do that manually. So I don't know. They're still using whatever. Refactoring clean code and style. A change made in the quote by Martin Fowler. A change made in the internal structure of a software to make it easier to understand and cheaper to modify without changing is observable behavior. The strategy. So if you want to refactor something, strategy, refactor the code first, then sync back to the prompt. For structural or stylistic issues that do not change observable behavior, instruct the AI to refactor the code directly, and then use a sync command to update the prompt documentation. For example, the AI-generated billing service implementation class contains some hard-coded magic numbers that need to be extracted into meaningful constants. Private, blah, 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 so some code. And then they prompt it to make constants out of these magic numbers. The AI executes the code, refactoring based on this instruction, remembers the golden rule, always refactor in small incremental steps. If the output meets our expectation, we use the /SPDD sync command to synchronize these newly updated code details back to their corresponding locations within structure prompt. Then you run it, the SPDD sync command, the AI summarizes the changes based on the rules defined in the SPDD sync command. It then follows the structural requirements based on the reasons canvas to write the detailed code description updates back into the corresponding sections of the structured prompt. Once both commands are executed, we can see all the prompt and code changes here. For any deeper or hidden code smells, simply repeat the steps. The golden rule is to always keep the structured prompt synchronized with your latest code base. Okay, so this for me feels much more like kind of vibe coding approach. So you let the AI generate code and then you improve it, and then they sync back to the initial, let's say, code prompt. Regression test, once all optimizing is complete, restart the service and run the API test script again. And then you see if it still passes, etc. Step 6, generate unit. So this test script is more like a kind of a quick kind of testing, and now they actually create unit tests. Let's read through it. Functional testing alone is insufficient for robust validation. Okay, it's obviously the shell file is a functional test. It acts primarily as an auxiliary check, and it's not factored in code coverage metrics. The final design sign-off on core logic requirements comprehensive unit tests. Currently, the SPDD workflow does not have dedicated testing commands finalized. This will be introduced in future iterations. As an interim solution, we utilize a template-driven approach to generate structured prompts for unit testing. Ooh, testing is not covered in the initial version, even though, ThoughtWorks is built on top of test-driven development. Now they don't deliver a test-generated proper. Okay, anyway, I'm a bit of mean here, but it's just interesting that, testing falls off the table most of the time. Generate the initial test prompt. We begin by combining the implementation details with our standardized testing template to generate the baseline test prompt. Instruction based on the implementation details with the MD file, combined with the template of test scenario test template, please generate a test prompt file. Okay, so you also, it's kind of the same approach. You create a prompt file, which then produces the actual test. I'm not sure. I think I like the idea of having a lot of context, also a lot of context in MD files. But why copy code? Because code is also context. Anyway, they deduplicate and refine scenarios. After generating the initial structured test prompt, some of the proposed test scenarios were duplicates of what we already had. To address this, we continue to dialogue, instructing the AI to cross-reference the generated prompt with the existing test suite, identify the genuinely new scenarios, and remove any redundancies. Instruction: there are tests that are duplicated with existing ones compared to relevant tests that exist. Okay. Updated artifact generate the unit tests. Now we actually generate the unit tests. Once the refined test scenarios are reviewed and confirmed, use the finalized test prompt to drive the actual code generation. Okay, generate the unit tests. Results, all tests passed. I quickly want to check the unit tests. All right, so you have, where is it? Usage controller integration test. Okay, so you have one of the tests here, multiple tests. Okay, nice. Okay, so to summarize this example, what this example delivered. This marks the conclusion of the complete SPDD workflow. Through this standardized process, we successfully delivered the following key outcomes. A business logic implementation with exponentially high intent alignment, complete engineering transparency, including a clear understanding of the implementation path, technical decisions, and acceptance trade-offs, a structured prompt asset tightly synchronized with the current code base, laying a solid foundation for future iterations, compounding human expertise, fostering continuous accumulation of developer experience and mental models as we iterate collaboratively with the AI. Yeah, it's absolutely true. I really like this very controlled and transparent application of AI to generate code. It's a really, really proper approach. We also prepared a bonus enhancement feature. If you're interested in getting some hands-on practice, we highly encourage you to tackle it using the SPDD workflow, so you can also play around with it. So there is a new final, I think it's the final section, or not really, but let's tackle that too. SPDD is a material change. The three core skills: SPDD is a material change in how developers build software. In our work, we have identified 3 core skills that they need in order to do their work effectively. These skills reflect where the value of developers is shifting in an AI assistant world. Abstraction first. Design before you generate. Before generating any code, you need to be clear about what objects exists, how they collaborate, and where the boundaries are. Without that, AI often sprints on implementation details while the structure falls apart. Unclear responsibilities, duplicated logic, inconsistent interfaces, and the costs show up later in review and rework. So there is some additional... Okay, so there is some additional subpages with more content that explain this kind of core skill. Alignment. Lock intent before you write code. Before implementation, you need to make what we will do and what we won't do explicit and agree on the standards and hard constraints up front. Otherwise, you end up with fast output and slow rework. Iterative review. Turn output into a controlled loop. You want AI assistants to behave like an engineering process, not a one-shot draft. Without a disciplined review and iterate loop, teams either keep forcing the model to patch things until the solution drifts, or they restart repeatedly and lose control of cost and time. Yeah, so I would agree about this. Alignment, abstraction first, alignment, and iterative review. What I think is interesting, and it's not mentioned at least in this summary here, obviously, as a software engineer, it's no longer only the technical knowledge you need to build something. So abstraction first, alignment, and also iterative review is a lot about actually understanding the business goal or the intent behind the actual code generation. So I would even argue that, change in how developers build software. I'm not sure. So in these articles, developers are mentioned many times. And so the question is, what is actually the role of the developer anymore? So if I read at these core skills, the developer is no longer actually a developer. So it's like more like a intent to final product transformer kind of thing. And yeah, if you're a developer and you have technical knowledge, that's certainly a big advantage. But if you want the abstraction first, especially translation of business logic to kind of the software architecture in a way, you also need, let's say, domain skills and also, other skills than just these 3, I would say. Yeah, I saw this section before. I think it's also very important to address where SPDD fits and where it does not fit. Fitness assessment, SPDD is an engineering investment. The table below rates how well it pays off by scenario, from high-level recommended 5 stars to not suitable 1 star. And yeah, it's interesting to see that they gave a 5-star rating for scale standardized delivery, high repeat business logic that needs long-term maintainability, building many similar APIs, automating core business workflows. Also 5 high compliance and hard constraints, environments where you must follow regulations, security standards, or strict architectural rules, like financial core system, multi-channel, multi-client deployments. Yeah, a bit less, a 4-star, team collaboration and auditability, multi-person delivery where changes must be fully traceable and reviewable end-to-end, cross-cutting consistency, complex refactors where logic must stay tightly synchronized across multiple microservices or different languages. A bit less of a fit, 2 stars, firefighting hot fixes, stop the bleeding production fixes where speed matters more than architectural discipline. Then also 2 exploratory spikes when a goal is to validate an idea quickly rather than ship production quality software. SPDD's governance overhead won't pay back. Also 2-star one-off scripts, disposable data cleanup, and temporary scripts where SPDD upfront cost is too high relative to the value. 1-star context black holes when the domain is poorly defined and business rules are unclear. You can't set meaningful boundaries for the model. Also pure creative visual work, tasks driven by taste and aesthetics rather than logic, UI visual exploration and marketing copy. Yeah, you see that SPDD as a kind of a engineering method. It's clear that when you have a big project, kind of slow moving, you want to apply AI, you probably want to implement such a rigorous process. If it's purely exploratory work and also creative work, it doesn't really make sense to have this structured approach. Trade-offs to consider: return on investment. Determinism with SPDD is high, speed immediate, what you get, encode logic in a precise spec, which significantly reduces hallucination and creative interpretation. Traceability is also high, speed is immediate. Every meaningful change can be traced back to the structured prompt, closing the audit loop. Faster reviews is also high, speed short-term, code arrives closer to the team standards, so reviews focus on logic and design, not formatting and cleanup. Explainability, medium high, gradual intent and behavior are visible at the natural language level, lowering the cognitive load for understanding and maintenance. Saver evolution is also high, speed long-term. Well-defined boundaries and stepwise implementation make targeted changes low risk and easier to iterate. Upfront investment, it's a mindset shift. Barrier is high. Nature, ongoing training, what it takes teams to have to adopt the design first rather than code first thinking. Senior expertise upfront. Barrier medium to high. Natural pre-feature engineers who can translate business rules into clean abstractions and design construct. This is exactly what I thought about before. So you really need senior expertise up front. So this is not a junior middle engineer thing if you want to work like that. Automation tooling, medium infrastructure setup. Okay, without automation, SPDD hits a throughput ceiling and struggles to keep prompts consistent. OpenSPDD runs the workflow in this article from analysis and structured reasoning, blah, blah, blah. So basically you need skills like this tool they use, OpenSPDD, to kind of automate that. That's, I think, is clear. Closing. By using the reasons canvas, clarifying intent, establishing the right abstraction, breaking work into concrete tasks, and locking in boundaries, we give AI a well-defined space to operate. Within that space, SPDD may not be the shortest path to generate code quickly, but it is one of the most reliable ways to ship the right change with confidence. It's also fair to say that SPDD shines most in logic-heavy domains. In areas driven by aesthetic judgment, front-end styling, for example, we are still exploring engineering patterns that can be as stable as purely logical constructions. Yeah, this I think is very, very important to point out. If you build like whatever enterprise rules engines, etc., this very structured approach is more important than obviously a marketing landing page for a website. The framework is in this article is on only the moves. The real advantages comes from sharpening the meta skills behind it, abstraction and modeling, systematic analysis and a deep understanding of the business as a whole. Those are the human strengths that ultimately determine how much value we can get from AI. In the AI area, software development isn't a contest of model IQ. It's a contest of engineering cognitive bandwidth, how clearly we can think, frame problems, and make decisions. We close with a quote that captures the spirit of SPDD. In science, if you know what you're doing, you shouldn't be doing it. In engineering, if you know what you're doing, you shouldn't be doing it. If you don't know what you're doing, you shouldn't be doing it. Yeah, I kind of agree. So there's a couple of acknowledgements and footnotes. Yeah, so it took quite a while to go through the article, and if you're still following along, yeah, I hope you enjoyed it. And I'm personally not overhyped about what they came up with. It's nothing completely new. I suspect that this multi-step process, I don't know. I kind of like it because it's, adding context layer by layer. But I don't really understand why you have to do these 1, 2, 3, 4, 5 steps. So at NetNode, we have a slightly different approach, even though we have mode 1, which is actually this analysis and contextual gathering and contextual gathering. In our process, it's called mode 1. And then we have mode 2, which is the implementation. So we only have 2 phases. So it's more or less like planning, getting context, and have a very direct exchange with the AI. No code is generated. Everything will be saved to a markdown file or task file. We can review it, share it with stakeholders, and then we implement it. And all the... we should do a video about it, how we do it. But all these norms and safeguards, as well the entities and approaches, they live in the code, for example, as a drizzle schema, or as the approach is typically given by the framework itself we use. So the rules or the norms we use, for example, if you use Next.js, there are ways how you build an API, there are ways how you deliver a page, and this is defined by the framework we use. Yeah, I would also not underestimate that AI itself, especially the frontier models, are very well in understanding what you try to do, and even understand it even more, can digest more context than a human can. I mean, they even kind of agreed on that, because it could find better or more edge cases. So so it's this balance between control and also having trust in the AI that it comes up with good solutions. It's kind of the same here, it's just like a more controlled context gathering analysis thing. And then the idea to have basically the coding prompt alongside the actual code. Yeah, we'll see what the future will bring. Maybe in the future we will just write these coding prompts, and this is actually what we produce with AI, and then we just give that to a runtime, and then we'll generate the software on the fly. I don't know. But yeah, certainly an interesting read, and we can learn a lot about it. And what I like about it is it's definitely not vibe coding. So, and for software engineers, there is definitely a future which is something like this. So agentic engineering and AI-based engineering is big fun, and it will be the future. So if you like content like that, consider subscribing. And until then, see you in the next one. Bye-bye.